Namaste. All right, good morning, guys. Today, I want you guys to do an activity on distance and displacement. Now, I started talking about this in the notes from 11.1, and today we're going to do a bit of an activity on it, okay? And so what I sent you guys was this worksheet right here that says distance versus displacement. And let me show you how to do it, okay? First, let me review the concept with you guys, okay? And the concept of distance is simply how far you go. Displacement is how far you go with respect to a start point. Okay, so, and if you remember, distance is a scalar, it's just a number, and like temperature. And displacement is not just it's two numbers, it's a size called a magnitude, also with a direction attached to it. Now, direction can be north, south, east, west, or direction could be right or left, or in mathematics, oftentimes direction is given the sign either positive or negative. So that's kind of that's how we design or delineate direction. Okay, now it's important to know, obviously, like why you're learning distance and displacement. All right, as it's important to know everything it is that I teach you. And the reason, very simply, is because we came up with a concept because nature seems to work that way. We don't really dictate what goes on; nature does, and we just kind of come up with a mathematics to describe what actually happens in nature. And here's what I mean. So here's a good example. So I'm going to draw two people. So here's a guy. Here's some dude. All right, and he's standing there. Okay. And I'm just going to come up with a random name for this guy, so I'm just going to call him Gavin, I don't know, Nurmi, or something like that, just some random name, all right? And then here's some other guy, and he's standing up, okay, on a high place, like this, and there he is, like that, and, okay, and he's got a big rock, and he's going to drop it on Gavin's head. Okay, and this other guy, we'll just some other random name for him. We'll just call him like Tommy Turner. I don't know, just some random name that I'm coming up with. Okay, and so Tommy Turner is going to drop the rock on Gavin Nurmi's head. And the question would be, what would be funnier if Tommy Turner dropped the rock from point A, or if Tommy Turner dropped the rock from point B? Now, most people, if you're a nice person, you would say, oh, point A, because you wouldn't get hurt as much. But if you're, some other person who takes pleasure in other people's pain or something like that, I don't know, like maybe Taylor Stevenin or something like that, you would say, drop the rock on Gavin from point B. Why? Because it would hurt more, okay? And we take pleasure in other people's pain, so that's why we think that stuff is funny. Okay, so anyway, and it would hurt more. Why? Because the rock is higher up, and we'll get into this. We'll get into this a little bit later. The rock has more what's called potential energy up there, and it would give that energy to Gavin's face upon impact. At point A, it has less potential energy. The point being, and here's what I'm getting at with distance and displacement, is that the rock hitting Gavin from point B is higher up. The height above Gavin's head is a displacement. It has a beginning, it has a start point and an end point. Okay, it's not a distance. Nature cares about the outcome of the situation is determined by gravity. Gravity, according to nature, works on displacement, not a distance. What I mean by that is, it doesn't matter how Tommy got the rock to that point. The outcome of the situation only depends on the 2 points, the release point and the end point. It doesn't matter how the rock got to that point. So it doesn't matter if Tommy lifted the rock straight up to that point and then dropped it on Gavin's head, or if Tommy took some random path with the rock, which would be a longer distance, and put it there and then drop, it would still be the same outcome. Why? Because the distance that the rock went through to get to that point has no effect on anything. Okay? The only thing that has an effect is the displacement above Gavin's head. That's why we have this concept called displacement, because nature works that way. Okay? So I'm gonna do, we're gonna do this exercise, and this is your assignment for today. And I'm gonna do the first one. I'm gonna do the first one with you. And so what you have is you have a number line up there, and it says trip number 1, trip number 2, all the way down to trip number 12. Okay, and I don't care if you guys print this out and then do it on there, or if you just look at the screen and you get a chart going of distance and displacement. And then it says route, like something that you would walk, okay, or whatever. And so, and here's how it works. So route number 1 goes like this. It goes from 0, okay, -7, 5, 8, -2, and then -3. So what you're going to do is you're going to pretend you're standing on the number line, and you're going to start at the first number, and then you're going to walk to the various numbers. And then we're going to find out what is the distance. We're going to count the distance in, let's say, paces, okay, and the displacement. Okay, so let's say we go the first route, and we're going to start at 0. Why? Because it just says to. So, and then we're going to walk to -7. So if we go from 0 and we walk to the left to -7, 1, 2, 3, 4, 5, 6, we walked a distance of 7 paces. Now we're at -7. And then we're going to walk all the way from -7 all the way past 0 to +5. That's a +5, not -5. Okay? So if we walk from -7 to +5, how far do we walk? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 paces. So from -7 to 5 is 12 paces. So this is 7 paces, this is 12. Now we're going to go from +5 to +8. So we stopped at +5, now we're going to walk to 8. How far do we go? 1, 2, 3. So it takes 3 more paces to get to the number 8. Now we're going to walk from number 8, and we're going to walk all the way down to -2. So how far is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So from 8 to -2, you would walk 10 paces. Now from -2 to -3, how far do you walk? Well, that's obviously 1 pace. -2, just take 1 more step, and you're at -3. So that's 1. So let's look at the distance that we walked. Well, we walked 7 plus 12, that's 19, plus 3 more is 22, 10 is 32, plus 1 more is 33 paces that we walked. That's our distance. Remember, distance is just how far you go. Doesn't matter what direction you go in. Okay, so we walked a total distance of 33 paces. What's our displacement? Well, displacement only depends on 2 points, the first point and the last point. Okay, so where do we start off? Well, we started off at 0. Where do we end up? We ended up at -3. So how far is that? Well, that's 3 paces. But remember, displacement is a vector, and you have to give it a direction. So in this case, if we're on number line, what's the direction? Well, the directions are either positive or negative. And we wound up 3 paces to the left of our start point, so we're going to put a negative sign on it. So our displacement is -3. Tracking? It's actually pretty easy, all right? I'm actually going to do number 2 also with you, and then I'll let you guys do the rest, all right? So I'm going to erase this. I'll put number 2 up here, and then we'll do it. So number 2 is -3, -5, 7, 10, 7 again, and then 4. Okay, so let's find our distance and displacement. Now, a lot of people screw this up because at this point, because they'll say they think you have to start at 0. You don't. All right. In this case, the last one we started at 0. In this one, we're starting at number 3. So we're going to pretend that we're standing on -3. Sorry, not number 3, -3, and we're going to walk the route that the route tells us to walk. So we're going to go from -3, and we're going to walk to -5. So what is that? 1, 2. So it takes 2 to get to negative 5. Now we're at negative 5, and we're going to walk all the way. We're going to pass 0. We're going to walk all the way to 7. How far is that? So negative 5 is, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it takes 12 paces to get to number 7. Now we're at 7, we're going to walk to 10. Now I'm only going up to 8 there, but just do it in your mind. So 7 to 10 would be 1, 9 would be another, and then 10 would be 3. So to go from 7 to 10 would be 3. Now we're going to go from 3 back down to 7. How far would that be? Well, that obviously, that would, if it took 3 to go from 7 to 10, it would take 3 to go back. So 10 to 7 is just another 3. Okay? Now we're going to walk from 7 to 4. So 1, 2, 3 to get to 4. Okay, so let's count up our distance. Let's find our distance, and let's find our displacement. So our distance is going to be 2 plus 12, which is 14, plus 3, which is 17, plus another 3, which is 20, plus another 3, which is 23. So we walked a distance of 23 paces. Okay, good. That's our what's our displacement? Well, again, your displacement only depends on the start point and the end point. So we started at negative 3 right here, and then we ended up at 4, positive 4. So what is that? 1, 2, 3, 4, 5, 6, 7. So our displacement, the size or the magnitude is 7. Now we have to give it a direction. If it's right, it's positive. If it's left, it's negative. So we wound up 7 paces. We started at negative 3. 7 paces to the right of where we started. So we're going to say positive 7. That's our displacement. If we wound up to the left, 7 paces, we would say negative 7. Okay? All right. So anyway, that's how you do this exercise, which is your assignment for today. So do that, and I will then post the answers a little bit later. Okay? And be sure to ask me questions if you're confused on this in any way at all. Be sure to ask me questions and come in during my office hours at 10 o'clock. All right, I'll be looking for you guys. Okay, check it out. Goal us out. Enjoy your apocalypse.